All right, so I'm on the very first page of your. So I'm on the very first page of your packets. So a lot of this is going to be reviewed from yesterday. All right. So 5.1 special quadrilaterals. So there are many special types of quadrilaterals, which is basically all the ones on the board. Shh. These special quadrilaterals become because of sides being parallel or perpendicular, and because there are sides of the same length. So they have very specific properties. All right. So we're going to skip the first question, besides the fact that it's all the ones we have listed. All the ones that you pretty much have learned about should have been trapezoid, parallelogram, rhombus, rectangle, and square. Now, here are some characteristics that define them. So trapezoids. So remember, that's the first child of a quadrilateral. It's any quadrilateral with at least one pair of parallel sides. So they could have either one or two pairs. So guys, as soon as you have two pairs, what does that trapezoid become? Not isosceles. If it has two pairs of parallel sides, what does that trapezoid become? It becomes a parallelogram. So even though, remember, parallelograms are technically trapezoids, but their defining feature is that since they have two pairs of parallel sides, that's what makes a parallelogram. So we're going to state whether these look like trapezoids or not. So we need to identify at least one pair of parallel sides if we can. So let's look at number one. Do you guys think that would be a trapezoid? Yes. So where are my parallel sides? So remember, you name sides with two letters. You name sides with two letters. So which two sides are parallel? E, not quite. E and F. That's the one. Yeah. So E and F, and what's its counterpart? HG. So because EF appears to be parallel, remember the double line means parallel to HG, we're going to say it's a trapezoid. What about B? Does it appear there's going to be parallel sides? Yes, no, maybe? No. So that's probably not a trapezoid. What shape could it possibly be? It could be a kite. All right, so it could possibly be a kite, but it's not a trapezoid. What about C? Do any sides appear to be parallel to each other? Yes, which side specifically? RS and QT, good. So since RS is parallel to QT, and remember, these arrow ticks are the symbol for parallel on a shape. We're going to say it's a trapezoid. Guys, please stop talking. What about D? Yes, what are my parallel sides? AB and DC. There's actually another set. AD and BC. So I mark the other set with two ticks instead of one, just to show difference. All right. Now, not only is this a trapezoid, it's a what? Nope. It's a parallelogram. So guys, when it comes to these shapes, we can only say it's something based off of what we currently know. We cannot eyeball and assume. And you'll learn that when we get into proofs. Innocent until proven guilty of being a rhombus. Innocent until proven guilty of being a parallelogram. But we can only do that with enough evidence. We have enough evidence to show that that's a trapezoid because we have at least one pair of parallel sides. We have enough evidence to show that that's a parallelogram because there's two pairs of parallel sides. All right. We don't have enough information about whether it's a rhombus or not because do we know if those sides are congruent? Nope. So we can't say that. So we can say it's a trapezoid. We can also say it's possibly a parallelogram. Now, E. Do any sides appear to be parallel? No. Does this appear to be any type of special quadrilateral? Which one? Nope. It can't be an isosceles trapezoid if it's not a trapezoid. It could be a kite if you turn it the other way, or it could just be a regular old four-sided shape or a quadrilateral. We don't know. We don't have enough information. And then this one, of course, it's going to be a trapezoid. They definitely look parallel. So, what sides? MAHT and good. Now, based off of what we currently know, not only can we say it's a trapezoid, what also could we say? It's a parallelogram. We can't say it's a square, even though eyeballing it looks like a square, but we don't know if all the sides are congruent, and we don't know if those angles are right angles. They could be 89 degrees for all we know. 89 and 91, all right? Looks are deceiving. So again, get it through your head now. Do not eyeball it, because trust me, they do that on purpose to mess you up. Innocent until proven guilty. It's like we're in court. That's why they're called proofs. You got to provide enough evidence to show that they are what they are. Now, the next one is parallelograms. So remember, parallelograms are any quadrilateral with exactly two pairs of parallel sides. So, given this parallelogram in exercise 3, A, B, C, D, what are my two pairs of parallel sides? So what's one pair? AD and BC. So AD is parallel to BC. So remember, this little symbol right here means parallel. And so when we mark it, I want to put a one tick arrow on it. What's my other pair? AB is parallel to DC. So because they're not parallel to AD and BC, I'm just going to put two ticks on them. Remember, the ticks, it's a matching game. 1 to 1, 2 to 2, so on and so forth. It's the same thing when you mark congruency and when you mark congruent angles and congruent sides. All right, it's just matching. Now, list all angle pairs that must be supplementary. So we know that what angles are congruent? A and C are congruent. What's the other two? B and D. So I'm going to mark those with two ticks. So what angles have to be supplementary? So remember, supplementary angles in a parallelogram are which angles? What type? The consecutive sides. So they can't be supplementary and congruent at the same time, unless they're right angles. That's the only exception. So which angles are supplementary? Either way. A and B are. So B and D is not because they are opposite angles, but A and B are because they are on the same side. They share a side. What's another set? D and C. What's another set? We already got, did you say C and D or C and B? C and B. Good. So just because they're on a different side doesn't mean that they're not supplementary. And what's the last one? A and D. So your parallelogram should have 4 sets of consecutive angles, meaning that they're supplementary. Should have 2 sets of opposite angles, which are congruent. Now, using the above, give an argument for why the measure of angle A must be equal to the measure of angle C. So we already know that they're congruent based off of what we know about parallelograms, but let's say we didn't. All right. But we knew that we had some supplementary angles in there. How could I say that angle A is congruent to angle C if all I knew was that they shared some supplementary? What could I use? Look at the overlap that I circled. Aren't A and C supplementary to the same angle? Yes, which angle? B. So A and C are supplementary to B. So that means that if angle A plus angle B equals 180, and angle C plus angle B equals 180, doesn't it stand to reason that since we have both with angle B in them, and they have to equal the exact same thing, doesn't it mean that A would have to equal C? Right. This is what we call substitution, or the transitive property. They basically mean the same thing. All it means is that we take, if we have it so that they equal to something, or if they add with another, oh my God, hold on. If they add to the same angle to equal 180, or if they're equal to the same angle, you can switch them out. All right. So since they both can add to B to equal 180, I can switch the C and put it in place of the A, and vice versa. Now, the subcategories of a parallelogram. So these are the ones so in this class, we don't really do a lot with trapezoids. We mostly exclusively deal with the parallelogram family. So everything below a parallelogram. So we have rectangles, which are quadrilaterals with 4 right angles. So it's a parallelogram with 4 right angles. The rhombuses, or the rhombi, are quadrilaterals with 4 sides of equal length. So in other words, all sides are congruent. And then the squares are the incestuous babies of the rectangles and rhombuses. They have both the right angles and the congruent sides. So we are going to look at these shapes and name them based off of what we know. Only based off of what we know. All right? We can't make any other assumptions. So you can't just eyeball it. You've got to do it based off of what we know. So look at letter A. What do we know? We have 4 right angles. All right? So we can assume that this is a what? We can assume it's a rectangle. Nothing else. Now, since it's a rectangle, that also means it's a parallelogram. That also means it's a trapezoid, etc. But a rectangle is like the lowest of the subcategories that we can say that is. What about this one? So they marked parallel for 2 sets of sides. So what is the only thing that we can assume that is? Nope, not rhombus. So we have 2 sets of parallel sides, so we can assume that it is a parallelogram. But that's all we can assume. We can't assume that all the sides are congruent. We can't assume that they are 90 degrees because nothing's marked as such. Now, this one, different type of tick mark. What do the straight line tick marks mean? Congruent sides. And remember, it's a matching game. So each side has 1 tick mark. All right. So that means they're a rhombus because all four sides are congruent. That's all we can assume. All right. So this one, we have both 90-degree angles marked and sides marked. So we can assume it's a square because it has both. Huh? It's probably because one note. All right, now be careful with this one. We have a set of parallel marked, but we also have congruency marked. So what is this? It's a trapezoid because it has one set of parallel sides, but we can go further and say it's isosceles because it also has two congruent sides. So we can say this is an isosceles trapezoid. Which, remember, isosceles is just a fancy name for saying two sides are congruent. Now, this last one, think about this carefully. We have congruency marks. So the 1 ticks are congruent and the 2 ticks are congruent. What would you call that? What can we assume this shape is? It's a kite. Why? Because there's 2 pairs of consecutive sides congruent. So they can't be opposite sides because that means that they're directly across from each other. Consecutive sides mean they meet at a point. All right, so these 2 are consecutive sides and these 2 are consecutive sides. So we can call this a kite. So again, when it comes to these, you gotta understand that we cannot assume unless told otherwise. All right, or if we have enough information to prove otherwise. So that's 5.1. Now let's go into 5.2. So go to page 5. So with 5.2, all right, what I want you to do is, and you can work with your group mates, I want you guys to go through and fill in both these tables. So I'll do parallelogram with you for the first one. So we'll do number 1 as an example. So you're going to check what's true. So in a parallelogram, does a parallelogram have 4 sides? Yes. Does it have opposite sides that are parallel? Yes. Does it have opposite sides that are congruent? Yes. Are all the sides necessarily congruent? No. Are the opposite angles congruent? Are all their angles congruent? No. All right. Now let's do the diagonal one too. So parallelogram, do the diagonals bisect each other? Yes. Are the diagonals necessarily congruent? No. Not for a parallelogram. Do the diagonals bisect opposite angles in a parallelogram? No, not in a parallelogram. Are they perpendicular? No, not in a parallelogram. So that's how you have to go through these. And remember, we're talking about the base level of each shape, not like what they can have children turn into. We want to know their parents. All right, so work together with your group and fill in the rest of these tables. I'm going to give you guys 7 minutes. So it's quick. So use that journal entry, that'll help you. So again, you might want that journal entry out because that will help you. Literally went over all of that yesterday.
Rhombuses are the same as parallelos. So except for Dumb.
Talk with your group mates. They'll help you out. Yeah, because don't they have all the properties in their library? Yep. So what you're going to discover is that there's a lot of overlap. All the properties that are
Do you on this square or the square down are they? Wait, what? Yes, just do they match the square?
For which one?
A square?
Well, what does a square overlap with?
It just has everything.
You're such a cheater. No.
Trey, the lesson video information is posted already in the morning, so you need to go back and watch that. You guys got about 3 more minutes until the timer goes off.
So does it look like this? Which one? Which for what? For rectangle and square. Oh, angles are rectangle. Like this. And then what it does it look like that? What about the second tab? What'd you get from your table? Is it the same? I hate this because I only have to do this. I don't think they're doing this. Not today. Miss Murphy, are we doing this? Do you want this to it?
We're doing it now.
Do you want us to?
Not yet. I just want you to film the table. So make sure you fill in both tables.
So just reach it up. It's not the cat.
Guys got about a minute and a half left.
I don't answer. Oh, so you drank the cat? No, I just drank cycle. So decaf? No, it's just cat. It's just regular. So no sugar. Decaf means there's no caffeine. Oh. Decaffeinated. That's reminding you to start drinking. I think the sugar. I think it's more expensive. I feel like it's higher. in like breakfast. Yeah.
Okay, thumbs up if you're ready. Alright. Let's go over it. Alright, so let's go group 1. Does a rectangle have 4 sides? Yes or no? Yes. Group 2, are the rectangle's opposite sides parallel? Yes. Group 4, are the opposite sides congruent? Good. Group 5, are all sides congruent? No, not in a rectangle. Group 6, are opposite angles congruent? Are the opposite angles congruent in a rectangle? Yes or no? Yeah, let's see. Yes. Group 7, are all angles congruent in a rectangle? You sure? It's yes. Why? Why are all the angles congruent in a rectangle? What's the measure of all the angles? 90 degrees. So obviously they're going to be congruent. All right. Group 8. Does a rhombus have 4 sides? Yes. Group 9. Are the opposite sides parallel? Group 1. Are the opposite sides congruent? Yes. Group 2. Are all sides congruent? Yes. In a rhombus they are. Group 4. Are the opposite angles congruent? Yes, they are. Group 5, are all angles congruent in a rhombus? No. Now, for a square, I can tell you right now, you're going to check off all of them. So, just from this table alone, what do you notice that's consistent? So, in other words, aren't these columns all filled in for these 4? And the reason that they all have that because they stem from a what? The bottom 3 stem from a what? Parallelogram. So they share all the features of a parallelogram. Now, look at a square. Isn't it true that a square shares the all congruent sides with the rhombus and the congruent angles with the rectangle? Yeah. Because remember, a square is an incestuous child of a rhombus and a rectangle. All right. Now, that means that for the next one, for all 3 of these underneath, they bisect each other. What should I do? Check them off because they share that with a parallelogram. Now, since a parallelogram has none of the other ones that are true, we have to go based off of our gut. So, are the diagonals of a rectangle congruent? Yes or no? Is a rhombus? Are they congruent? No. Are squares congruent? Yes, because the square shares properties with a rectangle. Do the opposite angles do the diagonals bisect the opposite angles in a rectangle? Meaning they cut them in half? No. Do they do that for a rhombus? Do they do that for a square? Yes, because a square shares properties with a rhombus. Are the diagonals, do they intersect perpendicularly? Not in a rectangle. What about rhombus? Yes, they do. So a square has to as well. So you gotta know these properties. Now, last thing we're gonna do is we're gonna answer some true or false questions. All right? At least for the packet stuff. So, here's what I want you guys to do. When I ask the question, I want you to put thumbs up if you think it's true, thumbs down if you think it's false. All right? But don't raise them until I tell you to. I want you to think about it. So, first one, all quadrilaterals are parallelograms. Is that always true or can it be false? Think about it. All right, raise your thumb in 3, 2, 1. What do you guys think? Thumbs up, thumbs down. Definitely thumbs down. Because, so it's saying that all quadrilaterals have to be a parallelogram. What's a counterexample that makes that false? An isosceles trapezoid. An isosceles trapezoid is not always a parallelogram. All right. What makes it a parallelogram is two sets of parallel sides. An isosceles just has to have one. All right. Now, number 10, all parallelograms are quadrilaterals. Think about it for a second. So all parallelograms are quadrilaterals. Is that true or false? Raise now. That is 100% true. Parallelograms, no matter how you slice it, will always be a quadrilateral, meaning a four-sided shape. All right, number 11. A square is a parallelogram. Think about it. Raise. Yes, a square is a parallelogram always. So guys, these true or false, I'm talking about always true. Like this will always be true. But if you can think of one condition where it's not true, it's false. All right. 12. A parallelogram with a right angle is considered a square. True or false? Think about it. Raise. Definitely not, because what exists? Rectangles. It's false. Because just because it has a right angle does not mean all four sides are congruent. 13. All rectangles are parallelograms. Is that true or false? Think about it. Raise them. That is 100% true. A rectangle will always be a parallelogram. All rhombuses are squares. What do you think? True or false? Think about it. So every rhombus that you will encounter will be called a square. Go. Definitely not. Why? Why? What about a rhombus does not necessarily have to happen in order for it to be a rhombus? Right, the angles don't necessarily have to all be 90 degrees. All right. If they are 90 degrees, that's what makes it a square. But not every rhombus is going to have all four angles being 90 degrees. 15. All squares are rectangles. So a square will always be considered a rectangle. Think about it. Raise. That is a 100% true. All right. A rectangle is the father of a square. All right. Because a square is a shape with 90-degree angles. A rectangle is a shape with 90-degree angles. The only thing that separates a square from a rectangle is a square has all congruent sides. But as long as it has those 90-degree angles, a square is a rectangle. Now, the next one. A parallelogram with four congruent sides is always going to be considered a square. Think about it. What do you think? Definitely not, because what other shape exists with four congruent sides? Rhombuses. And since a rhombus is the father of a square, that means it's false. Last one, a parallelogram with perpendicular diagonals is always going to be a rhombus. Think about it. All right, raise them. Guys, that's 100% true. All right. A rhombus is the first time that you see perpendicular diagonals. All right. So parallelogram with perpendicular diagonals, that's enough to say it's a rhombus. All right. Any questions about these, true or false? Nah. All right. So now why we're doing this for 5.2. Well, 5.2 is all about proofs. Now, you touched on them in Math 2, or at least you should have, but if you don't remember, that's okay. But in Math 2, you did triangle proofs. So do you guys remember, like, the congruency stuff? So, like, side, angle, stuff like that? If not, we're about to review it. But that stuff is congruent triangles. Now, in Math 3, we take it a step further, and we take some of the stuff from congruent triangles, and we use that to help us prove if quadrilaterals are a specific type. So, like if it's a parallelogram, a rectangle, square, etc. We also use it to help us find, like, identify if two different sides are congruent. There's a lot of different ways that we can use proofs. All right. Now, we're not going to get into the meat of proofs until Monday. But today what we're going to do is we're going to go through we're just going to review the basic triangle stuff because you're going to need that for quadrilateral proofs, as well as talk about some basic proof statements and reasons. All right, so you need that blue sheet. All right, so first off, nope, I want the front. We're going to start with proving congruent triangles. Now, this is completely review from Math 2. So, if you have certain things marked, all right, if you have certain things marked in a triangle in a certain order, you can have enough information to prove that they're congruent by any of these postulates. So SSS, ASA, SAS, AAS, and HL. Now, SSS, what do you think that stands for? Side, side, side. Side, side, side. So what that means is if you have two triangles, all right, you will have 3 sets of corresponding sides that are congruent. And corresponding is just a fancy word for saying they're in the same spots. They just might be oriented differently. So like those two triangles, if you notice, 1 tick to 1 tick, 2 tick to 2 tick, 3 tick to 3 tick. All 3 sides have a matching partner on the other triangle. So if we have 3 sets of congruent sides, we can say that these triangles are congruent. Then we have side angle side, so SAS. So that stands for side angle side. So that means that we have 2 sides that are congruent. So 2 sets of corresponding sides that are congruent. Now, we also have what we call the included angle. So this angle is known as the included angle, which is just a fancy name for saying between the 2 sides. So in other words, this angle would be the included angle. So do you notice how this angle is actually made up of the 2 congruent sides? Yes, no, maybe. Yeah. So this angle is made up of the 2 congruent sides. So if the angle that's made up of the 2 congruent sides is also marked congruent, you can say that the triangle is congruent by side angle side. Now, you don't need to erase this, and I'll draw it back in a second, but if, let's say this angle was marked, that is not side angle side because the angle has to be made up of the 2 congruent sides. This is called side-side angle or ASS, all right? Think about what that says in your head. If you spell it, angle side side, ASS. We do not want any asses in class, all right? So that's true for anything with triangles. Side-side angle or what it spells backwards does not prove congruency. Side angle side does. Now, we then have the ones that have two angles and one side marked congruent. Now, the next two are very similar, but they're slightly different. So, angle side angle. So that means two angles, so two corresponding angles are marked congruent. Now, so we have angle, side, angle. The side that is marked congruent is the side that is directly in between the two angles. So in other words, what I tell my students is that if you drew a line from the first angle where it's marked to the second angle where it's marked, you would have the congruent side that you went to. All right, so if you drew a straight line, the side that's marked would be that line. So this is known as the included side. And again, that just means it's between the two angles. Now, not to be confused with angle side angle, we have angle angle side. So again, two angles are marked, but the side that's marked is not between the two angles. So, in other words, if I drew a direct line from one angle to the other marked angle, it would not be the side that's marked. Does that make sense? The difference between the two. So that is angle, angle, side. And just note that that side is what we call the excluded side. So in other words, it's not between. Now, the last postulate only works in a very specific case. So, hypotenuse leg. So, hypotenuse leg. What is the only type of triangle that you know that has hypotenuse? A right triangle. So, hypotenuse leg works for right triangles only. So, hypotenuse leg works for right triangles only. Mahogany, we're on that blue paper. So, that just means if the hypotenuse of the two triangles are congruent and one of the corresponding legs, then the two triangles are congruent. And remember, the hypotenuse is always across from the 90-degree angle. Now, if we can show congruent triangles, the other thing that we have, all right? So if we can show congruent triangles, we can then prove that any part of said triangles are congruent by what we call CPCTC, which just means corresponding parts of congruent triangles are congruent. So it says the corresponding sides and angles are congruent. So for example, let's say that triangle ABC was congruent to triangle DEF. All right. So A, B, C, and D, E, F. So if I know that those triangles are congruent, what sides have to be congruent? And note, I did not orient them the same way. So the way you can tell, put on my desk. So the way you can tell is read the way it's listed. All right, the corresponding sides and angles are with the way it's listed. All right, so what's one set of corresponding sides? AB and what's its corresponding side on DEF? So if we have AB, so that's the first two letters, so what should the corresponding side be? DE. So do you guys see how AB is the first two letters, DE is the first two letters? That means they're corresponding. So what's another set of corresponding sides? BC and EF. Because BC is the second two letters, EF is the second two letters. So that means our last set is CA and FD because it's first and last, first and last. So literally, the way you name triangles, you always name them with their corresponding parts together. So that means which angles are congruent to each other. So which angles would be congruent to each other? C and F, because they're the last letter. What's another angle? Or set of angles that's congruent to each other? B and E, those are congruent. And what's the last one? A and D. So guys, it's literally based around the order of which they wrote the names of the triangles. So what that means is if we know the triangles are congruent, we can mark any part of that triangle congruent as long as they're corresponding parts. And again, corresponding parts means same spot. So corresponding literally means same spot. But just note that they may be oriented differently. So one may look like it's rotated or reflected or something. But if you turn them the same way, they would look to be in the same spot. Now, that's what we need to know about congruent triangles. So we're going to be using that a little bit when we get to proofs on Monday. The other thing that we need to know is some of the statements and reasons involving proofs. So, how this works is I'm going to give you some very general statements and reasons. And then we're going to draw diagrams of what they would look like if you actually look at them. All right. So, the first one, all right, is if I have, let's say that I have a shape, I'm going to call it A, B, C, D, and there's a line drawn from B to D. I can say that side BD is congruent to side BD. Now, why do you think I can say that? Where would that come in handy? So let's say I was trying to prove that these two triangles were congruent. Why can I say that BD is congruent to itself? Don't they share that side? Yes. So it's congruent to itself. Now that has a very fancy name. It's called the reflexive property. So whenever you prove things, you can always say that something is congruent to itself, especially if they share that side or angle. So you can also do it with angles. So let's say I had two triangles, a baby one drawn into a big one. And let's call this angle E. This is B, A, D, C. And let's say I mark this angle right here. I can say that angle BEC, so BEC is congruent to angle AED, so AED, for the same reason, because it's literally the exact same angle. It's in the exact same spot. They share it. They share that angle. So that is the reflexive property. Now, the next one that I have doesn't necessarily have a diagram. Well, I guess I could draw a diagram. All right, so the next property that we have, we kind of already discussed this. So let's say that I have, let's say that I have like two triangles. I know that's three triangles, but let's just say I'm looking at these two triangles. So I'm going to call this A, B, C, D, E. Now, let's say that I said that angle BCA was congruent to angle DE, or angle DEC. So I said that angle BCA was congruent to angle DEC. I also said that angle CDE was congruent to DEC. So I can then say angle CDE is congruent, and I'm just making up scenarios, guys, to DEC. Thus, couldn't I say that angle CDE is congruent to angle BCA because they're congruent to the same angle? Yes, no, maybe? Yeah, I can. Since they're congruent to the same angle, I can say that these two angles are also congruent. All right, so we already called that, it's called the transitive property. And it's also known as substitution. So it just means that if you know that two sides or angles are congruent to the same side or angle, you can say that those two sides or angles are congruent to each other. Same thing like if you know that two angles are supplementary to the same angle, then those two angles have to be congruent. All right. Now, let's do a little bit of parallel line properties. All right. So I'm going to mark these two angles, and I'm going to call this angle 1 and angle 2. So I'm going to say that angle 1 is congruent to angle 2. Why? Who remembers what property tells us why that is? Let's review for math 2. Alternate interior angles. So the reason is alternate interior angles in parallel lines are congruent. All right. We also have, I have another set of parallel lines. I can say that, I can say that these two angles are congruent, so 1 and 2. So angle 1 is congruent to angle 2. Why? What's the relationship between those two angles? So again, this is review for math 2. You already learned this before technically. So who remembers what that relationship's called? They're not vertical. Yes, good. They're corresponding. So because corresponding Because if you look, don't they look like they're in the same spot, just shifted? Yes, so corresponding angles in parallel lines are congruent. I can also say, if I have another set of parallel lines, I could say that this angle are supplementary. So angle 1 plus angle 2 is equal to 180 degrees. Why? They're same side interior. Same side or consecutive. They may be labeled as consecutive. Same side interior angles in parallel lines are supplementary. Now, some other type of angle relationships you'll see. So let's say I had crisscrossing, and those two angles were marked. I can say angle 1 is congruent to angle 2. Why? What's the relationship? So it's not parallel line relationship, but there is a relationship. What's the relationship? I'll give you a hint. One of y'all said it earlier, but it was incorrect. Vertical. They're vertical angles. Vertical angles are congruent. Now, let's say I had something like this. All right. Angle 1 and angle 2. First off, those two angles will be what? Supplementary. So angle 1 plus angle 2 is equal to 180 degrees. Now, why are they supplementary? What's that picture technically called? I'll give you a hint. It's two words. First word starts with an L. Last word starts with a P. Linear what? Linear pair. Good. So a linear pair is supplementary. Now, those are all angle relationships that you will see. Another relationship that you will see is, let's say you had a segment, a line segment. Let's call it AB. And let's say C was the midpoint. All right. So what does a midpoint mean it does? It's in the middle, which means what? It's half of each. So can I not say that AC is congruent to CB? I can say that. And the reason you can say that is because that is literally the definition of midpoint. It cuts a segment in half, or it's halfway down a segment to where it creates equal distance on both sides of it. You can also say that about a segment bisector. So let's say that this line, BD, was a bisector. So if BD bisects AC, so segment BD bisects AC, what does that mean? We talked about this yesterday. What does a segment bisector do? It splits it in half. So if BD bisects AC, that means that on either side of it, it's two congruent segments. So let's call the point that they intersect at E. Which, by the way, that would make E the what of AC? The midpoint. So that means that AE is congruent to EC, because that's the definition of segment bisector. We're almost done, guys. A couple more reasons. Now, there's also angle bisectors. So let's say I have this angle. I'm going to call it ABC. And the segment, let's call it BD, bisects. So this is an angle bisector. What does an angle bisector do? It cuts the angle in half. Yeah. So that means that those two little pieces of the angle are congruent because it's cut in half. So we can say that angle ABD is congruent to angle DBC. So ABD DBC. Because again, that's the definition of an angle bisector. It cuts it in half. Now, we already talked about this one, but let's say we wanted to show that triangles were congruent. So A, B, C, and D, E, F. All right, let's say we already showed that triangle ABC is congruent to triangle DEF. That means that we had to use one of our congruence postulates, which remember that's on the previous page. So just know that the congruence postulates are on the other side. So that is side, 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 angle, 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 side, and hypotenuse leg. To prove triangles are congruent, you got to use one of those postulates. Now, lastly, let's say that we're using the same picture from up top. And let's say that we said that side AB is congruent to side DE. So we already shown that the triangles are congruent. So triangles are shown congruent. That's the important part. The triangles have to already be shown congruent. Then any corresponding side or angle we can say is congruent by CPCTC. Corresponding parts of congruent triangles are congruent. So again, we can do the same thing for an angle. So angle So let's say angle BAC is congruent to angle EDF. Again, we already shown that the triangles are congruent. So again, we can say it's by CPCTC. So these are some fairly common reasons, all right, to show that things are congruent, supplementary, things like that. All right, so here's the thing. There is a very, very, very short delta math. It's just reviewing the congruence postulates of triangles. All right, so you just have to identify if the triangles are congruent or not and by what postulates. So hold on to that sheet because we're going to be using it a lot next week.